Automation can lower risk and improve operational agility of F5 big IP configuration. Depending on the size of the environment and business requirements, automation may or may not be the right answer. Frequently, a quick one-time change via manual configuration may be simpler. However, as the complexity and scale of the environment increase, you may need to address business requirements with one or more approaches for scaling big IP config. Let's summarize options for scaling your big IP operations and environment. First, the simplest approach for consistent configuration of Local Traffic Manager, or LTM, is to utilize policies for defining how traditional load balancing is performed. iRules offer advanced traffic manipulation, allowing for real-time decisions based on application logic. AS3 enables declarative automation, simplifying configuration management through JSON-based templates. Finally, iControl REST API allows for dynamic programmability, giving teams the flexibility to integrate Big EP into broader automation workflows. We will also explore how these approaches integrate into various workflows, allowing teams to optimize their Big IP strategy for efficiency and scalability. Consider this scenario: a network engineer tasked with setting up a highly available web application. Using the Big IP service portal, they quickly configure virtual servers, pools, and monitors. Within minutes, traffic was flowing seamlessly between multiple backend servers. However, over time, new applications were added, and management of traffic became more complex. Each new application introduces unique handling logic, such as routing based on URI paths, HTTP headers, or specific request parameters. It also became harder to perform A/B testing, where traffic had to be split between two backend versions for comparison. Without a flexible way to direct traffic conditionally, testing new features in production became slow and inconsistent. To tackle these challenges, the network engineer created a manual LTM policy to inspect HTTP request headers and apply conditional logic. A use case involved checking for a custom header in the request. If the expected value matched, traffic was sent to a new pool of application servers running the updated backend. All other traffic defaulted to the existing production pool. This setup allowed for phased rollouts and A/B testing within the production environment. The engineer configured this manually in the Local Traffic Policies section, creating a rule with a condition that matched the header and assigning the appropriate forward pool action. This approach gave them control over deployment strategies without requiring changes to the application code or the need for external tools. As the infrastructure scaled, there is a need for more consistent and frequent updates with coordination across multiple Big IP instances. The manual approach of configuring LTM policies in the GUI became time-consuming and error-prone. The network engineer decided to export the configuration to an SCF file and extract the relevant LTM policies manually. Next, he applied the changes to each Big IP instance using the config merge feature. This approach worked well for a few instances, but as the number of Big IP devices grew, it became increasingly difficult to manage. The engineer realized that while LTM policies were effective for small-scale deployments, they needed a more scalable solution for larger environments. A security engineer needed a way to redirect mobile users to a different subdomain while keeping desktop users on the main site. He decided to use iRules, which is a scripting tool built into Big IP that lets you control traffic behavior. He wrote a short TCL script that checked the type of device making the request. If the device was mobile, the script redirected the user to the mobile version of the site. If it was a desktop device, the user stayed on the original page. To see if the logic worked, he applied the iRule manually in the Big IP user interface. Using the Big IP UI to apply an iRule is simple. In the console, the engineer went to the Local Traffic section and clicked on iRules. From there, he added a new rule by pasting the TCL code. After saving it, he attached the iRule to a virtual server by picking it from a drop-down list. This made it easy to try out changes without using the command line or restarting anything. However, as the number of iRules grew, managing them became challenging. The engineer found it hard to keep track of which iRules were applied to which virtual servers. He also faced problems with version control and testing changes before applying them in production. Developing a structured plan is key to address these challenges. Git for version control and Ansible scripting to automate delivery of iRules. Typically, a plan includes setting up automated pipelines and validation tests for change management. which is what our engineer also did to transition from manual iRule management. Consider a NetOps engineer faced with manually configuring big IP environments. Each deployment involves repetitive tasks, increasing the risk of errors as the infrastructure grows. Seeking a solution, they turn to an infrastructure as code approach that could integrate seamlessly into their CI/CD pipeline. One major issue was ensuring that every big IP instance across development, testing, and production environments had identical configurations. Minor discrepancies could lead to unexpected behavior, affect application performance, and cause delays in deployments. That's where AS3, a declarative API, allows them to define big IP configurations in JSON format. Instead of making repetitive manual changes, the NetOps engineer can write a simple JSON file describing the required setup. Using the F5 extension for Visual Studio Code, they can open the AS3 file, edit the configuration, and deploy it directly from the editor. With AS3, they can define application services like pools, virtual servers, and monitors in a single place. To scale AS3, the team could create an Ansible playbook that reads the AS3 declaration from a file and applies it to multiple big IP instances. This way, they can ensure that all environments are in sync with the desired state defined in the AS3 declaration. While AS3 required learning its schema and had some limitations, it brings increased efficiency and the first step towards automation they had been searching for. A cloud architect needed real-time control over their big IP infrastructure. Their team had already automated deployments with Terraform and Ansible, but they faced a major challenge. Network traffic patterns were unpredictable, and application demands fluctuated throughout the day. Manual interventions to adjust configurations and optimize traffic flow were time-consuming and often resulted in delays, impacting application performance. To address this, they turned to iControl REST API, enabling them to dynamically modify configurations, collect analytics, and troubleshoot issues in real time. However, another problem emerged. Ensuring that API-driven changes did not introduce inconsistencies across multiple big IP instances. Without proper synchronization, conflicting configurations could disrupt traffic flow. To solve this, the cloud architect developed an automated workflow that validated and deployed API changes in a controlled manner. They built scripts that enforced policy consistency across all instances and implemented automated rollback mechanisms in case of failures. Additionally, they integrated monitoring tools to analyze API responses and detect configuration drift before it could cause service disruptions. The flexibility of API calls made them an indispensable tool for automation strategies, enabling rapid adjustments and proactive traffic management. Scaling big IP config can range from simple manual changes to fully automated DevOps-tooled workflows. Teams often start with manual methods and evolve toward automation as their infrastructure grows. Let's look at each option from basic control to advanced automation. At the most basic level, LTM policies offer quick and easy configuration through the Big IP Service portal. This method is ideal for small teams that need to make fast changes without complex logic. It works best when you have a few services and don't need to automate every step. Next, iRules offer more advanced traffic control using custom scripts. While they are still applied manually at first, iRules let engineers build logic for things like device-based redirects or security checks. As needs grow, teams can automate iRule deployment using simple scripting or automation tools, which improves consistency and reduces manual errors. This is often the first step toward automation for security-focused teams. For teams ready to automate at scale, tools like Terraform and Ansible are ideal. Terraform supports a declarative infrastructure as code approach, helping ensure consistent provisioning of big IP resources across environments. Ansible uses a task-based model that's easy to adopt, especially when teams already have existing playbooks for infrastructure tasks. Both tools reduce the need for manual configuration and make scaling much easier. At the far end of the automation path, GitOps with Jenkins CI/CD brings full integration between app development and infrastructure. In this model, configuration changes are made through Git commits. Each commit automatically triggers updates through the pipeline, allowing for quick, repeatable, and secure changes. This is the best choice for organizations with mature DevOps practices. Across all these approaches, AS3 provides a consistent way to declare configurations using JSON. AS3 can be used with any of the automation tools mentioned, and is a powerful way to ensure big IP devices are always in sync with your intended state. By understanding these options, from simple GUI changes to full GitOps pipelines, teams can build a roadmap that fits their size, skills, and goals. Starting small and adding automation over time helps reduce complexity while improving reliability and speed. Each approach to managing big IP comes with its own strengths and limitations, making it essential to choose the right tool for the job. For those who prefer a hands-on approach, LTM policies offer the simplest starting point. These are configured through the Big IP Service Portal and are very easy to use, requiring minimal experience. Deployment is fast for small changes, but scalability is limited. LTM policies are best when traffic control needs are basic and predefined, without advanced customization. iRules add more flexibility for teams who need custom logic. While iRules do require some scripting, they're not overly complex and allow for real-time traffic modifications, like routing based on device type or user behavior. They offer faster deployment compared to full automation tools, but can become harder to manage at scale. As environments grow, iRules benefit from version control and automated testing to prevent mistakes. They're ideal for medium-sized deployments where unique traffic conditions must be handled manually or semi-automatically. Terraform provides a declarative approach to infrastructure as code. It requires learning its own syntax, but once templates are written, provisioning is fast and consistent. It supports scalable deployments and makes it easy to maintain the same setup across multiple Big IP instances. Terraform is well suited for DevOps teams aiming for automation without giving up clarity or repeatability. Ansible offers task-based automation using YAML playbooks. It's similar in complexity to Terraform, but focuses more on managing configurations after deployment. Once playbooks are created, teams can quickly roll out consistent changes across environments. Ansible works well for ongoing updates and complements tools like AS3 for structured, repeatable deployments. At the most advanced level, GitOps integrates infrastructure changes with application development. Using a CI/CD pipeline such as Jenkins, any change made in Git automatically triggers updates. This approach has the highest complexity, but enables the fastest, most secure workflows. It allows full version control, automated rollbacks, and total synergy between app and infrastructure teams. It's ideal for mature environments with strong DevOps processes. By mapping each option to your team's complexity, speed, and scalability needs, you can adopt the right combination of tools and evolve over time, from quick manual updates to complete automation pipelines. It is stable, reliable, and perfect for administrators who need full control over their configurations without delving into automation. AI can accelerate the creation and editing of F5 Big IP iRules. While there are multiple GPT models trained on publicly available information, as a good starting point for creating or working with basic and intermediate iRules, they do not replace experts versed in iRules to handle more complex scenarios. Using a custom GPT can help accelerate routine traffic control and security enforcement tasks expressed through iRules. A custom GPT is an AI model that uses custom instructions, behavior settings, and training data. Unlike a general AI model, a custom GPT is built to understand a particular topic, process, or set of best practices to make it more accurate and useful for specialized tasks. If your organization has access to Big IP AI Assistant, as of spring of 2025 in preview, we recommend using it to work with F5 Big IP iRules. As a next best approach, however, we will walk through configuring a chatbot with a customized GPT model to help us work with iRules. Let's use the OpenAI platform to quickly customize a chatbot specifically for F5 Big IP iRules development. It will be context-aware, meaning it can follow the flow of a conversation, remember what was asked earlier, and respond in a way that makes sense. This will help produce more accurate and relevant answers, especially during troubleshooting or when working through complex logic. Besides understanding questions about iRules, the chatbot can also generate useful code examples and suggest ways to improve your code, including pointing out possible security issues. First, we need to define chatbot behavior. This includes setting detailed instructions, focusing on F5 Big IP iRules, and making sure the responses are accurate and easy to understand. In this segment, we'll go step by step through the setup. You will see exactly what to copy and where to paste it, so you can build your own iRules assistant with clear instructions that guide you through each part of the process. Now that we understand the purpose of the custom GPT, let's take a look at how it works in practice. To create a new GPT, first open the OpenAI platform, then go to the Explore GPTs section. From there, click on Create to start building a new chatbot. Now, open the Configure section. This is where you set up the main features of your chatbot. Start by uploading an icon, and next, choose a name. For example, F5 Big IP iRules Developer. Add a short description, and next, set up the instructions for your GPT. These guide the chatbot's behavior to help it understand iRules development. After that, it's time to set up conversation starters. These are helpful prompts that users can click to begin using the chatbot. Some good examples are, create an iRule to redirect HTTP to HTTPS. Can you optimize this iRule for performance? Or check this iRule for security risks. These make the chatbot easier to use, especially for people who are new to iRules. You can also customize the chatbot's personality and knowledge. This helps it respond in the right tone and understand the right context. You can even upload extra documents like example code or official guides to improve its answers. Finally, after completing all the configurations, save your new GPT and deploy it. Now your new chatbot is ready to help users with F5 Big IP iRules in a smart and interactive way. As part of the configuration, the chatbot was configured to function like an experienced F5 iRules developer. It follows F5's best practices to make sure iRules are efficient, secure, and easy to manage. It checks each iRule for unnecessary logic, possible performance issues, and security risks like injection attacks or poor error handling. It explains how each part of the iRule works with the big IP system. If a request is too general, like saying an iRule is slow or broken, the chatbot asks for more details before continuing. This includes the iRule code, any errors, and how the iRule is used. It also shares links to official F5 documentation and learning resources for extra support. Now that we've seen how the chatbot is set up, let's go through the first example. To begin, we use the predefined conversation starter. Create an iRule to redirect HTTP to HTTPS. By selecting this prompt, the chatbot immediately generates an iRule that performs the redirection. The chatbot then displays the functional iRule code snippet in the canvas, allowing for easy copying, editing, and interaction. To ensure users fully understand the iRule, the chatbot provides a detailed breakdown of each section. It explains how the rule captures HTTP requests and redirects them to HTTPS, highlighting key elements such as event triggers, conditions, and actions. This explanation enables users to grasp how the iRule functions, modify it according to their needs, and implement it confidently in their environment. We move to the next example, where we will test the chatbot's optimization capabilities. This will demonstrate how it can analyze existing iRules and provide suggestions for improvement. We are testing how well the chatbot can optimize an iRule. The user provides an iRule snippet that needs improvement. The chatbot reviews the structure and logic to identify parts that could be simplified or made more efficient. If more information is needed, it will ask the user for clarification. Once the chatbot has the necessary context, it explains how to improve the iRule. Each suggestion includes a clear explanation, so the user understands the reason behind the change. It may point out redundant checks, unreachable code, or unnecessary operations, like converting a URI to lowercase when it's not required. The chatbot might recommend using a data group to handle access rules instead of multiple inline checks. It provides an optimized iRule example using this method and explains how to set up the data group. This improves performance and keeps the code easier to maintain. It can also give improved iRule examples that are easier to follow, helping users learn how to write simpler and more readable iRules. We now successfully built a customized chatbot using ChatGPT to help F5 Big IP users with iRules development. The chatbot also helps users follow best practices by making complex topics like event priority and command scope easier to understand. Note, While the chatbot can give useful tips, you should always review and test the iRules, and of course, leverage the official F5 documentation to follow the correct methods. Follow your own judgment and your organizational policies to make sure the generated iRules are working as expected and are safe to use in production. These tools are here to assist, but the responsibility for accuracy and security ultimately lies with you. Happy iRules development! You may want to consider the F5 extension for Visual Studio Code for a consistent way to author and manage configuration. The extension enables contextual syntax highlighting, creating test scripts, exploring examples, and tools that make working with F5 Big IP easier. Let's have a closer look at this extension and how it can help you save time when managing Big IP config. The extension helps with editing long configuration scripts, replaces tedious manual checks for errors, and Visual Studio Code provides a framework for improving Git repo management, editing, and testing of your automation workflows. Syntax, highlighting, code snippets, and autocomplete features help you write code faster and avoid errors. Schema validation checks your configuration while you work to make sure it's correct. When you're ready to test, you can connect to your F5 device directly from Visual Studio Code. You can send configurations, get data, and manage deployments without leaving the editor. If you need to work in a different format, the extension can convert your configuration between JSON and YAML. If you need help, the extension gives you a set of examples to get you started. You can find sample configurations for AS3, declarative onboarding, and telemetry streaming. It also provides a set of links to the F5 documentation. You can quickly find guides, best practices, and troubleshooting steps. The command palette lets you run F5 tasks easily. The extension works the same on Windows, macOS, and Linux. So how do you get started? Step 1. Download and install Visual Studio Code from the official website. Step 2. Open VS Code, navigate to the Extensions Marketplace, and search for F5 extension. Click Install and you're good to go. Step 3. Configure the extension by adding your F5 device. Open the F5 panel in VS Code and click Add Device. Enter your Big IP login details, then press Enter to save. To establish a connection, click on the device, enter your password when prompted. The extension will now connect to your F5 device. Step 4. Install and manage RPM packages on the Big IP device to support F5 automation toolchain components. Open the F5 panel in VS Code and navigate to the ATC management section. Select the RPM and let the extension handle the upload and installation. Once installed, the component will appear in the list of ATC services, where you can manage it directly from the interface. On the screen, you can see an AS3 declaration in JSON format. This file defines virtual servers, pools, and monitors. The extension automatically validates the declaration as we edit. Once the configuration is ready and valid, we use the F5 extension context menu and click Post as AS3 declaration to send it to the Big IP system. This allows us to work directly in VS Code without needing to log in to the Big IP UI. The extension also sends log messages to the Output tab at the bottom of VS Code. This helps you see what the extension is doing during deployment, and it makes it easier to spot any problems or messages from the Big IP system. Additionally, the extension integrates with the Fast feature. With Fast, you can deploy applications rapidly using pre-built templates. You can also convert an existing AS3 declaration into a Fast template. This allows you to reuse a known good configuration and turn it into a repeatable template. After converting, customize the parameters using the HTML render feature in the extension. Then, apply the template to your Big IP system. This makes it faster and easier to configure applications right from your development environment. The extension comes with built-in commands that you can run from the command palette by pressing F1 or Ctrl+Shift+P. These commands help with tasks like connecting to or disconnecting from Big IP devices, running remote commands, managing configuration files, and sending AS3, DO, and TS declarations. You can also get device information, manage fast templates, and convert AS3 JSON to MST format. Using these commands makes it easier to automate and control Big IP directly from VS Code. If you need to work with telemetry data, the extension provides telemetry streaming management capabilities. In the examples folder of the extension, you can find a sample TS configuration. You can easily modify the configuration to suit your needs and deploy it directly from VS Code. The extension also lets you manage iRules and iApps for advanced traffic control. You can create, edit, and deploy these scripts right inside Visual Studio Code. The extension shows installed iRules and iApps, and you can easily add new ones. This is especially useful for developers who want to automate tasks like traffic management, security, and application delivery. This lets you focus on writing code without worrying about switching between different tools or interfaces. The extension also includes the Configuration Explorer, a powerful tool that enables you to browse configurations from bigipconf, UCS, or QKView files. This feature allows for easy exploration of extracted applications, helping you analyze and manage configurations without needing to manually inspect large files. For remote execution, the extension provides a remote command execute feature, allowing you to run commands on your F5 devices directly from VS Code. For additional support and features overview, you can quickly access official F5 documentation directly within VS Code. With all these features, the extension is designed to make automation effortless and efficient. The F5 extension for Visual Studio Code is more than just a plugin. It helps you automate F5 big IP tasks faster and with fewer mistakes. This extension is open source and available on GitHub. You can use it as is or change it to fit your own needs. Others in the community also share improvements. You can install the extension today and start working more efficiently. For more help, how-to guides, and examples, visit the F5 DevCentral community and check out the resources available there. In this module, we'll look at how BigIP keeps track of system activity, security events, and user actions. This helps with monitoring, troubleshooting, and managing your network. Before running automation workflows, it is recommended to understand how logging works in order to track the changes inside the system. This helps to quickly find errors or configuration issues. Without logs, automation can hide or compound problems or make them harder to find. Let's review how BigIP logging works to help us create automation that is safe, reliable, and easier to fix if something goes wrong. We will first look at system logs. These logs show problems with hardware or the BigIP system itself. Then we will look at TCP dump, which helps us see network traffic. After that, we will explore how to use iRules to create custom logs. Finally, we will discuss iCall, which helps with monitoring and alerting. BigIP log files contain useful diagnostic details about what is happening on the system. Some logs come from the Linux host that runs under the BigIP system. These include system messages created during boot, as well as logs from background services and daemons. Other logs are specific to the BigIP software itself. These show things like traffic handling events and configuration changes, including audit logs. Understanding both types of logs helps you troubleshoot and prepare for automation tasks. To view these logs, use tmsh and go to the var log directory. This folder contains most of the system and service log files that can help you find issues or confirm normal operation. System startup and hardware logs include the boot log file, which contains messages from the system startup, and the dmesg log, which shows hardware detected during the boot process. Kernel messages are recorded in the kern log. General system messages are in the messages log file, and user-level activities are tracked in the user log file. Service-related logs include the cron log for scheduled job activity and the daemon log for background services. The mail log stores messages from mail processes. Web server errors from Apache are saved in the httpd errors log. Security and access logs include the secure log, which records authentication and access control events. Changes to the BigIP configuration are saved in the audit log, which is helpful for tracking system adjustments. BigIP-specific logs include the LTM log for local traffic management events and the GTM log for global traffic manager operations. Logs related to the traffic management microkernel are saved in the TMM log. Monitoring activity is recorded in the LTM log and in more detail under the monitors log folder. The nsyncd log captures configuration sync operations. Other logs include the pkt filter log for packet filtering and the webui log, which records issues with the BigIP configuration utility's web interface. TCP dump is a tool that captures and shows network traffic. It helps you see packets as they move across a network interface. To start capturing packets, open your terminal and run the TCP dump command or use a web interface to do this. Here we tell TCP dump to listen to traffic on external VLAN. You can open this file later with a tool like Wireshark to see the traffic in more detail. In Big IP automation, TCP dump is helpful for troubleshooting issues that appear after automation tasks are done. For example, if there is packet loss or traffic is not reaching the correct pool member after you update a configuration using automation, TCP dump can help you check if packets are arriving at the big IP and where they are going. This helps you quickly find out if there is a problem with routing, load balancing, or NAT settings. By looking at the actual traffic, you can find issues that your automation scripts might not catch and fix them faster. F5 Big IP iRules are often used in automation to manage how traffic moves through your applications. When you are automating configurations or policies, adding logging to your iRule is useful because it shows what is happening in real time. This helps you understand how your automation is working and makes it easier to troubleshoot problems. Using the log command in an iRule, you can write messages to the Big IP log files. These messages can include key information, like when an automated rule is triggered or when a request matches certain criteria. This visibility is useful when you're testing automation scripts or verifying that changes work as expected. This kind of logging becomes even more valuable when used in different parts of Big IP automation. For debugging automation scripts, logging shows what actions the iRule is performing. This helps you quickly find where something goes wrong. For monitoring automated traffic management, logging helps you watch how requests are handled and if the automation is working as expected. For auditing changes made by automation, logs keep a clear record of events. This helps with tracking changes for security and compliance checks. For alerting during automation, you can log key events. Then, external tools can watch the logs and send notifications if something unusual happens, like a spike in traffic or a repeated error. In this example, iRule logs client connections and HTTP requests. The rule init event sets a variable called debug to enable or disable logging. The client accepted event logs the IP address of the client when they connect. The HTTP request event logs the hostname from the HTTP request. To use this iRule, first open the Big IP GUI by entering the management IP address of your Big IP device into a web browser and logging in with your admin credentials. Then go to Local Traffic, then click iRules. Click Create. Type a name for your iRule. Paste the code into the definition field. Click Finish to save it. Now go to Local Traffic and click Virtual Servers. Choose the virtual server you want to use. Under the Resources tab, find the iRules section. Select your new iRule and move it to the enabled list. To see the logs, go to System, then Logs, then Local Traffic. In the Big IP GUI, select LTM log. You can also use the filter box to search for the log messages. For example, you can search for logging iRule. This setup logs every client connection and HTTP request. It helps you monitor traffic and find problems quickly. You can also edit the iRule later to log more information or send alerts. F5 Big IP has a built-in automation tool called iCall. It helps with observability and logging. iCall lets the system react to specific events without using external scripts or monitoring tools. This helps keep the system stable without manual work. To show how this works, let's monitor CPU usage. If the CPU usage gets too high, we want Big IP to log a warning. We will do this using iCall. First, we create a script called CPU monitor script. This script checks the system's CPU usage. It compares the usage to a threshold of 80%. If the usage goes over 80%, the script logs a warning message. Then, we create a handler. The handler runs the script automatically every 60 seconds. This means the system checks CPU usage regularly without any manual steps. If usage goes over 80%, it writes a warning to the log. There is no need to install or configure any extra tools. You can also improve this setup by adding alerts or system changes if needed. F5 Big IP supports SNMP, which lets external monitoring tools check system metrics and receive alerts about important events. This helps IT teams see performance trends and catch issues before they become serious. SNMP traps are alerts that Big IP sends when specific events happen, like a system failure or a resource problem. These alerts make it easier to respond quickly and avoid downtime. Using SNMP with Big IP enables integration with network management systems, supports automated incident detection through traps, and provides consistent telemetry for troubleshooting. We reviewed the basic logging tools in Big IP, which help you understand how the system is working. You can check system logs, audit logs, and security events to find problems early before they become serious. You can also create custom logs using iRules. These let you track specific traffic or behavior. For example, you can log certain HTTP requests or changes to a virtual server. With iCall, you can respond to these events automatically. iCall scripts run when certain conditions are met, helping you take action right away. Before you start using automation on BigEP, it's important to understand how logging works. This makes sure your automated actions are based on correct and up-to-date information. With the right logging setup, you can fix problems faster, keep your system stable, and improve your automation.